Welcome to Thought Frontier.
Welcome back, everybody. Today we're taking a deep dive into thorium reactors, as a possible alternative to the usual nuclear energy.
Interesting you should say that.
We've got some articles and research papers.
Yeah.
And I gotta say, I was really surprised at how different thorium is from uranium.
Yeah, it's funny how often people kind of lump them together like they're the same thing.
Right.
But thorium's not something you can just directly use as fuel,
Mm-hmm.
like uranium.
Hmm.
It's more like it has potential energy locked up,
Okay.
and we need to figure out how to unlock it.
So we're not talking about splitting thorium atoms like we do with uranium.
Exactly. We're
Okay.
not splitting them. Instead, we use thorium to breed a special kind of uranium called uranium-233.
Oh.
And that uranium-233, that becomes the fuel for a chain reaction.
Interesting. And I was reading that thorium is way more abundant than uranium.
Oh, yeah, much more.
So could that change global power dynamics if this technology really takes off?
Oh, it could definitely shake things up. Many countries that don't have a lot of uranium, they actually have tons of thorium just sitting there. So if we could harness thorium effectively,
Yeah.
it could be a game changer.
That's a big if, though, right?
Yeah.
What are some of the biggest advantages of these thorium reactors? I know there's been a lot of talk about safety.
Yeah, safety is a big selling point for sure. For example, the risk of a meltdown.
Right.
With conventional reactors like the one at Chernobyl, a cooling system failure,
Yeah.
that can lead to a total meltdown disaster.
Yeah.
But thorium reactors, especially a type called molten salt reactors,
Okay.
they have these built-in safety mechanisms that really lower that risk.
Is that because the fuel itself is also the coolant? I was reading about that.
Exactly. You got it.
Yeah.
No need for those complicated external cooling systems that can fail.
And those were the problem at Chernobyl, right?
Yep. And even if there is an emergency, they have these grain systems that can quickly move the molten fuel into a safe configuration.
Oh, so it's great.
Prevents a runaway reaction.
Okay, so layers upon layers of safety. That's got to be reassuring for anyone who hears the word nuclear and immediately pictures a mushroom cloud.
I know, right? That's the image a lot of people have. But these designs are completely different from the older reactors that everyone thinks about when they hear nuclear energy.
So safer, but what about the waste? Isn't that a big problem with any kind of reactor?
Well, yeah, thorium reactors still produce radioactive waste. That's true.
Okay.
But they generate way less of it compared to uranium reactors. And here's the kicker. The waste from thorium reactors, it decays much faster,
Oh, wow.
which means it's only dangerous for a shorter amount of time. We're talking centuries instead of millennia.
Still a long time,
It is.
but much less than traditional reactors. That's a win for the environment, right?
And thorium reactors, like other nuclear reactors, they don't emit greenhouse gases, right?
Got it. They're carbon-free during operation, just like other nuclear power plants. And since they produce less waste overall, their environmental footprint is smaller.
There's even the possibility of using thorium reactors to help get rid of existing plutonium stockpiles,
Really?
which would be a huge win.
It all sounds almost too good to be true. Are there any downsides to this technology?
Well, of course, got to be realistic. One major challenge right now is the economics of it all.
Ugh.
Extracting thorium and building these reactors is still really expensive,
Yeah.
much more so than conventional uranium reactor.
Oh, yeah, that makes sense. New technologies are always more expensive at first. But if the demand goes up and research keeps moving forward, wouldn't the costs eventually come down?
That's what we're hoping for.
Yeah.
But there are other concerns too, like proliferation.
I thought thorium was supposed to be proliferation resistant.
It is. To a large extent, thorium itself, it's not easily turned into weapons.
Okay.
However, the uranium-233 that's produced during the thorium fuel cycle, that does raise some red flags. It's kind of a paradox.
How so?
Well, the IAEA considers uranium-233 to be just as risky as highly enriched uranium, the kind used in weapons. But there's a twist. It also produces this byproduct called uranium-232,
Okay.
which makes it really hard to shield against. But on the flip side, it makes the fuel easier to detect.
Oh, so it's like a double-edged sword.
Exactly.
Okay, so it's complicated. There are these security issues that need to be addressed, even though the overall proliferation risk is thought to be lower than with uranium. But overall, it sounds like thorium reactors have some serious advantages, especially when it comes to safety and reducing waste. It's interesting that some countries are already really invested in this technology. I
Yeah.
was reading that India has been doing thorium reactor research for decades.
Yeah, India's been a pioneer in this field.
They have a ton of thorium reserves, and they seem really determined to use them.
They do.
They've even got a 3-stage nuclear program
Right.
that's aiming to switch over to thorium-fueled reactors eventually.
Yeah, and what's really impressive is that they already have the world's only operating thorium-based experimental reactor.
Wow.
It's called the Kamenei reactor.
That's amazing. It sounds like they're way ahead of the game in thorium technology.
They are, but they're not the only ones making big moves. China is another major player in this field.
Right. I've heard about China's interest in thorium, especially their focus on those molten salt reactors.
Yeah.
What's driving their interest, and what kind of progress are they making?
Well, China has some serious pollution problems.
Right.
And they see thorium as a potential solution to their energy needs. They're investing a lot of resources into research and development with a very ambitious goal: commercial thorium reactors by 2030.
2030, that's right around the corner. Are they really that close to making it happen?
They've made some incredible progress. Recently, they pretty much finished building a 2-milliwatt thorium prototype reactor. And just recently, they got approval for their commissioning plan for a 2-milliwatt molten salt reactor.
Wow.
It's called the TMSR LF1, and it will be located in the Gobi Desert.
So they're going all in on this technology.
Yeah, it's pretty amazing to see these developments happening.
It makes you wonder what the future holds for thorium reactors and how they might change the whole energy landscape.
It definitely raises a lot of interesting questions.
For sure. And that's what we're going to explore further in this deep dive.
Yeah, it really is a fascinating story. And it's all unfolding right now in front of us. I mean, just imagine a world powered by a safe, abundant, and relatively clean energy source. Could thorium be the answer?
That's what I'm thinking. Before this deep dive, I had no idea thorium reactors even existed. It makes you wonder what other groundbreaking technologies are out there just waiting to be discovered.
Exactly. There's always something new to learn and explore. And with thorium, it seems like we've only scratched the surface.
Well, speaking of scratching the surface, I remember reading about some technical challenges that still need to be overcome before thorium reactors can really become mainstream.
Right. There are a few big hurdles. One of the biggest is how we get the thorium out, extracting it from its ore. It's called monazite. And it's not easy. It's not cheap either. It's a technical challenge, and it's just not economically competitive with uranium extraction at this point.
So it's like a chicken and egg problem. The demand isn't there because the technology isn't widespread, and the technology isn't widespread because the cost is too high.
Exactly.
Yeah.
And to make things even more complicated, building these reactors takes a lot of testing and research, which adds to the cost and complexity. It's a big upfront investment, even though the long-term benefits could be huge.
And I bet dealing with all the regulations is a headache, too.
Oh, absolutely.
Nuclear energy is one of the most heavily regulated industries out there.
For sure. There are all these strict safety protocols and licensing requirements that have to be met, and that can really slow things down. Plus, since thorium reactors are relatively new, there's a lot of work to do to figure out clear guidelines and standards just for this technology.
So it's a balancing act. They need to encourage innovation, but also make sure everything is safe. But even with all these challenges, it seems like things are starting to move. Countries like India and China are pushing ahead. And even here in the U.S., there's growing interest in thorium.
It really does feel like the world is waking up to the potential of thorium. I think as the research continues and the costs come down, we'll see thorium reactors playing a much bigger role in the global energy picture in the next few decades.
That's an exciting thought. But I gotta be honest, all this talk about nuclear reactions and fuel cycles makes my head spin a little. Can you break down exactly how these thorium reactors work? I think our listeners would appreciate a simpler explanation.
Of course. It's definitely more complex than just thorium goes in, energy comes out. Remember how we talked about thorium needing a little push to become fissile?
Yeah.
Well, that push comes from neutrons.
Neutrons, like the subatomic particles?
Yep, exactly. When a thorium atom absorbs a neutron, it transforms into thorium-233. And then that thorium-233, it undergoes radioactive decay and changes into different elements.
But hold on, radioactive decay. Can you explain that a little more?
Sure. It's a natural process where an unstable atom like thorium-233 emits particles and energy to try to become more stable. So thorium-233 decays into protactinium-233 and then finally into uranium-233, which is the fissile material we're after.
And that uranium-233 is what actually powers the chain reaction in the reactor.
That's it. It's a multi-step process, but in the end, you get a really potent energy source.
Got it. Now, I keep hearing about these molten salt reactors. What exactly are they, and how do they fit into all of this?
Molten salt reactors, or MSRs for short, are a special type of reactor that's really well suited for using thorium as fuel. Unlike conventional reactors that use solid fuel rods, MSRs dissolve the thorium in a molten salt mixture.
So the fuel is actually liquid. That's pretty wild.
It is, and that liquid salt does double duty. It acts as both the fuel and the coolant, circulating through the reactor core and transferring heat to generate electricity.
So it's like a 2-for-1 deal, fuel and coolant all in one.
Exactly. And this design has some big safety advantages. Since the fuel is already liquid, there's no risk of those solid fuel rods melting down and releasing radioactive material like in a conventional reactor.
Okay, so they're even safer than other types of thorium reactors.
They could be MSRs can handle very high temperatures, and the liquid fuel allows for passive safety features like emergency drain systems. So if something goes wrong, those systems can quickly move the fuel away from the reactor core.
Those passive safety features sound really reassuring. But let's switch gears for a second and talk about the waste. Even though thorium reactors produce less waste, what happens to it?
Well, we have to remember that even though there's less of it, it's still radioactive and needs to be handled very carefully. However, the waste from thorium reactors has a shorter half-life than uranium reactor waste.
Half-life, you mean the time it takes for the radioactivity to decay?
Exactly. And because the half-life is shorter, the waste becomes safe much faster. We're talking hundreds of years instead of tens of thousands.
That's a big difference. While long-term storage is still necessary, it's a much more manageable problem.
Right. And there's ongoing research into even more advanced waste management techniques.
Right.
Like transmutation.
Transmutation, that sounds like something out of Star Trek.
I know, right? But it's a real area of research. Basically, it involves using nuclear reactions to transform long-lived radioactive waste into shorter-lived or even stable elements.
Wow, that's incredible. So it seems like there's real potential to make the impact of nuclear waste even smaller. But let's talk about the bigger picture for a minute.
Yeah.
What are the global implications of thorium reactors? This technology could really change things if it becomes widely used.
Absolutely. It could completely reshape the geopolitics of energy.
Because right now, access to uranium is a major factor in global power dynamics. Countries with large uranium reserves have a lot of influence.
Exactly. But thorium is much more evenly distributed around the world. Many countries that don't have much uranium actually have a lot of thorium. So if we could figure out how to harness thorium effectively, it could shift the balance of power.
So it could democratize access to nuclear energy, at least in theory?
Yes, potentially. It could give countries the power to become more energy independent and rely less on uranium-rich nations. It could also level the playing field when it comes to nuclear technology.
That's a really interesting thought. It could change alliances, trade relationships, even global security. And we can't forget about the potential impact on climate change. Thorium reactors, because they don't produce carbon emissions during operation, could play a big role in reducing greenhouse gases.
That's true. And considering how urgent the climate crisis is, any viable carbon-free energy source is worth looking at seriously. If thorium reactors can be deployed safely and efficiently, they could be a crucial tool in the fight against global warming.
We've covered a lot of ground in this deep dive, from the basics of thorium to its potential to change the world. It's been an incredible journey so far.
Yeah, it's a lot to take in, but that's what these deep dives are all about, right? Giving you the information you need to make up your own mind. Exactly. We're not here to tell anyone what to think, just to equip you with the knowledge so you can understand this complex and always evolving technology.
I'll be honest, I had no clue about thorium reactors before this. It makes you wonder what other amazing technologies are out there just waiting for someone to discover them. It's really given me a whole new perspective on the power of research and innovation.
That's the beauty of knowledge, right? There's always something new to uncover. And with thorium, it feels like we're just at the beginning of a very exciting adventure.
Well, speaking of the journey ahead, let's talk about the bigger picture. Even with all the potential benefits we've discussed, there's still this kind of negative feeling around the word nuclear.
Yeah, that's true. You know, accidents like Chernobyl and the whole issue of nuclear waste disposal, it's made people pretty wary of nuclear power in general.
It's definitely an emotional issue for many people, that fear of meltdowns and radiation and the possibility of nuclear weapons. It's very real.
Yeah. Oh, I understand those concerns completely. But it's so important to remember that thorium reactors are fundamentally different from those traditional uranium reactors. That's what most people think of when they hear nuclear.
Right.
Thorium reactors are designed with all these safety features. And the waste they produce, there's less of it, and it doesn't stay dangerous for as long.
And we can't ignore the climate crisis either. We need real solutions to cut down those carbon emissions. And thorium reactors, they could be a big part of that.
Absolutely. The fact that China, with its massive pollution problems, is embracing this technology, that says a lot. They're serious about finding clean energy solutions.
That's a good point. Their commitment to thorium really suggests they see it as a way forward. So where do we go from here? What's next for thorium reactors? Is this all just hype, or are we seeing the start of a real energy revolution?
Well, it's tough to predict the future with absolute certainty. But the signs are pretty promising. Research is moving fast. Pilot projects are popping up. And more people are becoming aware of thorium. All the pieces are in place for a major shift in how we produce energy.
And as we talked about, the implications go way beyond just generating electricity. Thorium reactors could change global politics, empower developing countries, and help us tackle climate change. This technology has the potential to affect every part of our lives.
It's a really complex and fascinating story, and it's one that we'll definitely keep following closely. But for now, we want to leave you with this thought. Imagine a world powered by safe, abundant, and relatively clean energy. Could thorium be the key to that future?
It's something to think about as this technology continues to develop. Maybe someday we'll look back at this deep dive as the moment when we first caught a glimpse of a thorium-powered world. Until then, keep exploring, keep asking questions, and keep diving deep into the incredible world of knowledge.